Hello, welcome everybody. Thanks for the introduction. So, this is my screensaver, first of all. Running on my terminal built with Ratatui, which I'm going to talk about today. So, let's quit from this, start the presentation. All right, so today I'm going to talk about the renaissance of terminal user interfaces in Rust. And let's just start. Who am I and why am I giving this talk? In case the introduction wasn't enough, thanks for that again. My name is Orhun Parmaksız, and I've been an open source developer for some years now, and I mostly write command line tools and libraries using Rust, and I just live in the terminal, basically. And I've been leading the Ratatui project since last year, almost 2 years now, and on the side, when I'm bored, I package your favorite Rust tools for various distributions, mainly Alpine and Arch Linux, by the way. Here's my website if you want to check it out. So today, as I said, we're going to talk about Renaissance. And Renaissance simply means rebirth or revival of something. And to get an idea of what am I going to talk about and why this is a Renaissance, I'd like to start from basics and go back in time a bit. So, VT100. This is one of the earliest terminals, actually, video terminals, which changed the course of history. And the reason for that is it introduced something called ANSI escape codes, or ANSI escape sequences, or ANSI standard. Well, you might be asking why this is something big. Because back in time, every hardware manufacturer, they were just doing their own thing. There was a standard and so on. So VT100 came in and said, hey guys, let's have a standard, right? And this is what it looks like back in the day. And it basically like unified the terminal standards and so on. Well, what can we do using ANSI escape codes? You can basically control the terminal, control the cursor. You can do stuff like changing the lights on the keyboard. Does not sound like a very revolutionary thing, but it was good back in the time. Also, some people were into terminals and they wanted to have more in the terminal back in the day. So we were actually able to render some animations and art. Here's an example of that. This is an actual video of VT100 terminal. If you type this in, it contains an ANSI escape sequences, and you can basically render this. So these animations and these art pieces are not new. These were actually possible in the 80s and 90s. Twilight Zone. There is a website which actually collects these old animations and art files. You can go and check it out yourself. There are very interesting stuff in there, such as Bambi versus Godzilla. I don't know what were they thinking. But moving on, these files basically contain ANSI escape sequences, and this is what it looks like. Looks kind of gibberish, but when you just run this, or just, let's say, cat it on your terminal, you get these animations. There's a command called SV, I think. You can just stream the files and then basically see the animation that I just showed you. But ANSI escape sequences were not only for animations and stuff like that. After some time, people started to create TUI libraries. One of them is TurboVision. So this was basically one of the earliest examples of a TUI library, and this kind of influenced the other ones too. So TurboVision was mainly used for Borland Turbo's IDEs. And you might be familiar with this, this blue-looking Smurf theme. I think it's ugly, but shout out to them for creating TurboVision. And also, they were able to, you can use TurboVision to do other stuff, such as this TUI, which is DOS Navigator, just for exploring your file system and so on. So after ANSI became the standard, people started using the ANSI control sequences to build TUIs. But let's take a step back and see what a TUI is. Firstly, as I mentioned, TUI is basically an UI made using text characters. For example, you can see that I use some Unicode to draw something like a box. There's some text in the box, so basically this is just made using characters and looks like a widget or box or anything. Also, this is a code from Ratatouille. This is how we handle these characters. We basically have constants for these characters. We have some different character sets, so we combine these sets to render blocks or lists or, I don't know, gauge, progress bars, and so on. So this is basically how everything works. We just depend on text and text only and Unicode, which is a pain sometimes, but anyways. So TUIs are obviously designed to run in a terminal or console because this was the standard before. And this presentation right now, you're seeing this in my terminals, actually depends on these text characters as well. And shout out to Matthias for creating present term, which makes me able to present this to you with like images, GIFs, code blocks, and everything. So this is right now running entirely in my terminal. One other typical TUI example would be bottom. So this is basically a TUI for monitoring your system. You can see the processes and so on. This is basically a top alternative in Rust, thus bottom. And you might be familiar with htop. This is basically one of those tools for monitoring your system. Also, TUIs are efficient and lightweight because they run in the terminal. They depend on only text, Unicode characters, and so on. And hopefully, with the power of Rust, we are aiming to make them blazingly fast or faster, so to speak. GUIs, on the other hand, you might be asking, now, okay, TUIs are cool, but how about GUIs? What's the deal with them? Well, if you ask me that, I'll firstly want to explain bloat to you. So the best way to explain bloat is using memes. So for example, you install Snap package and the remaining space on your disk is just adios, it's gone. So bloat is basically something that takes a lot of space. It just, something big and so on. Other one is this one. Linux users, when they update, now their distro uses 28 megabyte more RAM than it used to. It's pain. Linux users, I know the pain on your faces, you know what I'm talking about. So bloat is basically, if something is using more memory than it should do, or if you don't like this situation, it's basically bloated, I guess. Also, this one, the Ultimate Swiss Army Knife, it even has a lightsaber in it. Jesus. So this is like another example. So bloat is basically having so many features in your application that nobody needs. In a nutshell, higher complexity and excessive features, complex interfaces, and also this will lead to performance issues, and you'll have profound sadness at the end of the day. I'm not even talking about Electron here. It's basically enslaved Chromium. Well, in the midst of everything, what's up with Rust and what's going on in the Rust/TUI world? Well, before Ratatouille, there was a library called TUI.rs. You might have used it before. It's now unmaintained. But I actually created my first Rust project using this library, and you can see the initial commit there, which basically kickstarted my journey in Rust. And this project is called Kmon. I can show it to you real quick. It's basically for monitoring your kernel and the kernel activities and so on. You can basically see the modules and the module descriptions and so on. After I built this, I got very positive feedback, and I really loved building this. So I was like, I should do more of this somehow. So I just kept going, basically. But then, after some point, TUI.rs got in an unmaintained status, and the author said that, hey guys, I don't have time. Maybe we should create a community around this project or create an organization, whatever. Let's make this thing alive. Don't let it die, okay? So me and other interested people jumped in. We created a Discord server. We had some meetings. Somebody came up with the name Ratatouille, which was a no-brainer to use. I mean, we just picked that one right off the bat. And somebody designed a logo. I have stickers, by the way. If you find me in the hall, I can give it to you after the talk. And after some time, we created some releases, and some people came in. We basically became a community project, and TUI got deprecated. And this is the advisory that deprecated TUI after some time. So when I talk about Renaissance, I actually talk about the new things or the new TUIs that Ratatouille brought to our world. And I will mention those at the end of the talk, but basically Ratatouille is aiming to give you a very simple way to build TUIs using Rust. So that's one of our points for the vision. And the other one is, I guess it's very obvious, but we want to make everything aesthetically pleasing and visually appealing. So these are our challenges, basically. In terms of ease of use, we want to give you the building blocks. We want to give you everything that you need to start building TUIs. For example, you will have scrolling as default, or embedded widgets, or and so on, and very simple examples. And visual appeal is just about theming, colors in the terminal, and so on. You can read more about this on the issue. We also care about performance and so on. So definitely check that out if you're interested. Well, what does it look like? I will run the demo. This is a demo of Ratatouille. It's a bit small because we record this on another terminal. But basically, what you can do with Ratatouille is you can have lists. Here's the actual recipe for the Ratatouille dish, for example. Or you can have tables, something like this one, for example. It's basically like a email client. Or some maps or some canvas if you want to draw some fun stuff. Or even like progress bars or gauges and different elements too. So we provide these widgets. You can use them to build stuff like this, basically. If you want to start development today, all you got to do is just install Cargo Generate, and you can use our template repositories. We have some templates, and it will create a Rust project for you. I will just very quickly show you the generated project. First, the main function, just very simple, creates the terminal and restores it for you, because when you're in a TUI, you're in a different terminal buffer. So we got to do that. And we basically wrap everything in an abstract. So this is the state of your TUI. It basically contains some methods. Hold on. For example, the run method is basically for rendering the TUI, rendering the widgets. And in that method, we call draw, and draw takes a frame and it draws a widget on a frame or multiple widgets. Event handling is also very easy. We use some backends for that, but basically you can handle the key presses and mouse events and so on. So quite straightforward to start out with Ratatouille. Here's a minimal example. If you want to see how it looks like. I want to go over these parts. For example, you start out with the imports, and then you create the terminal, and in a loop, you render your widgets by calling the draw function on the terminal, and then you can match. Basically, you can poll for new events, and just in this case, if anything's pressed, I just quit, and after the loop, I just restore. So this is how it looks like. And if I run this, hopefully you will see just the hello world text and a block surrounding it. So there are some concepts. Firstly, I mentioned loop or rendering loop, and why this is important, because we use immediate mode rendering. So let's say you have a state. Let's say you have a toggle variable. Based on the state of this toggle variable, you can either render a bar chart or line gauge, because this is giving you some flexibility, because we redraw everything for every frame, and using just one state, you can basically have dynamic UIs, basically. An example for that is this one. I just have this very simple TUI, and when I press something, you'll see that it switched to another view, but all I do is just render a widget or another one. So Switching context in the UI is just easy as that. So you just use the states. Also, we have a lot of widgets. Here are the main ones. And the common thing about widgets is that they implement the widget trait. So let's say you want to have a custom widget. For example, you want to render something that shows you some random colors. So random color widget. And you're going to use a random number generator to change the color of each cell in the terminal. So how are you going to do that? You're basically going to implement the widget trait on that struct. And the important part is this trait gives you a buffer, and the buffer has functions such as cell mut, so it gives you a mutable cell. So on this cell, you basically can set the background color or set some text, set some string, and so on. So rendering using a custom widget is just as easy. And to use that widget, you basically have to first construct it, and then just give it to the draw function in the that you get from the terminal. And one other important thing that I should mention here is that you want to poll for new events, so you don't want to block the render loop. So you're going to pretty much have a timeout here. I should have just used 16 milliseconds, which is roughly 60 FPS. So that's how you can basically have this widget in your TUI app. If I run this, you'll hopefully not get blind, but it looks like that. So the buffer has some methods other than the cell and so on. For example, setString just sets the string in the buffer, and you can actually get the underlying buffer from the terminal if you want to do testing. For example, I just test the contents of the buffer here. So in your TUI app, you can use test backend, which is a backend that we provide, and in your tests, you basically get the buffer from this test backend, and you can just assert whatever that you have, which is just a string. This also makes it possible to do snapshot testing. I added a recipe for that to our documentation last week, which works quite well. We use Cargo Insta, so you have your snapshots, basically the UI as a file, and then you use that file to compare against the actual render functions. So yeah, that's how it works, and the underlying buffer pretty much looks like that. So we have a symbol and also a style, and that's pretty much it. So you can also use dynamic layouts, which can be helpful if you want to change the UI based on some state. To do that, you can split the area horizontally, for example, using some constraints. And these constraints basically say that have like 10 characters or like 70% or minimum 5 characters and so on. And let's say you want to have a function which resizes the UI based on some length of something. You can basically say something like the message percentage will be based on some message count. So based on this value, you basically say that, hey, I want to have like the 80% of the screen or 50. And with this logic, you basically have like dynamic layouts based on your content. To get an idea of how this works, and also see how constraints look like, I recommend checking the examples. So in Ratatouille, we have this example, which shows you like different constraint types. For example, minimum ones, or the length, or percentage ratio, and fill. And if you want to have something more interactive, you can use the Constraint Explorer example, which gives you an UI which you can use to play around a bit. Let's say I want to have one percentage, let's have, I don't know, 60%. And I want to add another constraint. I want to have maximum 5 characters, and maybe another one on the middle. I want a ratio 1 to 5. And based on these constraints, you can see the flex layout. So maybe it would be better if you use flex. So we support flex too. And you can basically play around like this, have other constraints, have fun like that. And if you're asking about flex, we also have a flex example, which shows you how different constraints play with each other. You can just scroll here, have an idea of what's going on, and yeah, basically start using it in your app. Miscellaneous stuff, styling is super easy, first of all. You want to style text like something in a red color, you just call .red on a string, you got color text. You want to make it bold, you just call bold, or you want to maybe have more control. If you want to use RGB, you can do it. I have a example here, which just shows you, it's just super easy to render style text. Macros too, if you like macros, we have a Ratatouille macros project outside of the Ratatouille, and you can basically import this, and it gives you very nice macros. One of them is constraints. If you don't like writing everything line by line or just having everything explicit, you can use the constraints macro, which looks like this. For example, you want to have a 50-character constraint and then maybe 30% of the screen and so on. It's basically doing that in the macro. If you already have logging or tracing in your app, it's also very easy to integrate a widget called TUI logger in your TUI, and basically it gives you like a separate view in your app, and you can switch to the TUI logger and filter for your application logs. For example, I want to see the tracing logs for the cross term. I just increase the logging verbosity, and I want to just reduce the other ones, for example, or I want to do something else, I can just do that. And you can basically browse your logs using this widget. It's a matter of just adding this to your app and just rendering it, and it will just give you the log view out of the box. So I guess this is the part that everyone was waiting for, showcase. Well, now we can render animations in the terminal thanks to Ratatouille and a project called aficionado. Basically, this is what we can do. Let me show you the other ones. So let's say you're building a TUI and you want to have these animations. It's super simple to add them. Just add this library to your project, and you just render the animations on top of, like, as a one layer upper to your the widgets, and you'll just have these animations running. So yeah, it's quite cool, I think, and super easy to integrate. Also, this is another example from their repo, just to show you how you can render animations. These are just animations, and then I can change the interpolation, have some graphs in a animated way, and so on. So this is basically what you can render using Ratatouille. Moving on, we have Snake AI. So this is a neural network project and AI project which runs in the terminal, and you can simply watch AI learning to play the game Snake from the terminal. So if I run this, you see this UI, which, there is a Snake game, and here is the output and the stats and everything. And why this is good, you might be asking, because you don't need any UI, like graphical layer, to render any of this. You can just render this in terminal. It takes no resources almost, and basically watch whatever you're doing, monitoring your AI model or whatever. So yeah, it's quite an impressive project, I think. Moving on, we have a game, Kartoffels. This is a game where you're given a potato and your job is to implement a firmware for it. And it basically looks like this. So there's a template repository which you can use, and it gives you like a Rust API, and you write these programs. And after you write these programs, you need to either SSH into this server, or you can also use the browser to play the game. It's entirely the same UI. Either go to this website or just SSH into it. And after you write the program, you basically are greeted with this game. There's a tutorial, and you can just start playing if you want. It's quite fun. So the objective is to write the Rust program in the most efficient way, so that your bot, your potato, will be the most efficient in a dungeon or something like that. So here's how it looks like. And these are the other players. You basically, so how you play it, okay. You write your Rust program, you get the binary as base64, and you basically upload the base64 here, and you just spawn in their arena. So that's how it works. So yeah, it is how that works. Also, there is, if I go back, there's a tutorial which just goes through each step, and also you can have like have a playground to test out your bot and so on. So yeah, basically how it looks like. I'm gonna go back and quit this. You can also use the mouse, which defeats the purpose of the terminal, but anyways. I created Binsider a month ago, oh no, I don't remember. So this is my project. I was into reverse engineering a bit, so I created this tool which you can just run on any Linux binary and gives you some tabs to work with and some like static analysis features, some dynamic analysis features. You can run the binary, get the system calls and so on. You can search for strings, do a hex dump. So just a humble promo for my project. This is another project of mine. So this will be a throwback to the VT100 animations. If you remember the video that I showed you while talking about the animations, it is not possible to render the same animations using Ratatui in a terminal. So I made this tool called Theater. If I run it, you basically see the exact same animation, but rendered using Rust and Ratatui in my terminal. And you can also browse the other animations too, because I wanted to see what people have built in 80s. And they're very, very different things in there. I don't want to, okay, anyways. It's a bit risky because you never know what's going to see. I don't want to, okay, let's move on. So if you want to learn more and see the other apps, there's an awesome repository. We basically curate every new or very popular app there. Definitely check that out. So this will be the end of my talk. If you want to reach out, here are my links, Orhun Dev, and also I'm Orhun on GitHub. My socials, I'm not looking for a job, but yeah, we can talk. Ratatouille links, and the slides will be on this GitHub repository. Thank you, everyone.